Hi, it's me again. Wow, it's been a very long while since I've uploaded. And I'm sorry for that. I've been busy with my own stuff. Haven't really had time to really record another video, or I just couldn't really figure out for a while, like, what should I do afterwards, or right now. Recently, I've looked into a new way of creating this water material inside of Unreal Engine 4, and I must apologize right now for my crappy mic quality. A couple years, well, a while ago, just probably a couple months actually after the original video, the adapter for my microphone died, and I haven't had the time to really go and replace it and find something more proper than just a cheap £5 adapter. Anyhow, yeah, I'm bringing you this tutorial to kind of so you can kind of see recreate this kind of shader, which is actually much cheaper than doing everything mathematically inside of a shader graph, and I'll show you how. So what I'm going to do is, just for, because I have multiple planes running, so I've got more geometry to work with, which is not stretched out like thousands of kilometers away between another. So yeah, so what I'm going to do is reset this to defaults, so we just have a clean plane here. And this is a level I have assembled for a while now, and I might have to patch these two little areas up, but that's not what the video is about. Anyhow, so what we're going to do is go into our content browser and just, I don't know, just place it anywhere. I'm just going to create a new folder and just call it water shader tutorial. Yeah, no spaces. Tutorial, and we'll just put in here. So we'll just create a new material like normal, right click, and then I'm just going to call it mat/ocean or water master. Then once you get going, you get your shader graph, and yeah. So first things first, what you're gonna have to do is this is a surface material domain, but we're not gonna go translucent or any of these, in fact. And what we're gonna do is go into our shading model and instead use default lit and turn it into a single layer water. Now, sadly, we're going to be using this, but what we're going to have to do on top of that is add in the single layer water material output, which is over here. And I'll get into talking about this, what we will do in a minute. So I'm just going to place about there, because these two are working in tandem together, but this works. This is what actually gives the color, the opacity, and the depth, and that's based on how you define it in the shader graph. So first of all, what we're going to do is work on our. Actually, yeah, let's do the single layer output, because this is actually our most like, just so you get like an idea of what you're gonna see once you plug in like just all the numbers in. So the first two pins are going to be using a 3 vector node. So essentially, your 3 vector color is correction. Gonna convert into a parameter so we can instant this layer on, and you can just change the values at runtime to match to whatever you want it to be. So this is our scattering. Actually, instead of doing that, because I'm lazy, instead we can just do this, right click, and then from it to parameter, and there you go. And it's not the one I wanted. That's not the one I really wanted. so instead we go into we do like this, convert it to a parameter, call it scattering coefficient. I can spell. I've always learned any keywords, so I'm still trying to adjust my hand to it, like just my typing abilities. So yeah. So first of all, it's going to go into here, which will change up the color service. Our default number will be 0.000607. Our green channel will be 0.00182, and nothing after that. And finally, our blue channel will be 0.00243, and that's it for that one. And I just realized I made a typo right now. I'm going to just quickly change. And there you go. And we'll just plug it into our scattering coefficient. And we'll just apply this for now. Actually, you won't be able to see a result at the moment. So there we go. Unreal is actually responding. So instead, first we're gonna have to do is set up our basics NV main shader output. So what we're gonna do is create a free vector, convert into parameter, and then I'm just gonna call this liquid, and just leave it at that at 0001. So it's just black, and plug it into base color. Then we can just promote the parameter. Metallic is going to be 0 for now. Specular, we're going to give it a default value of a quarter. Roughness will be immediately to 0, which is what we need. So it will be very shiny and glossy, which is what we want. Our opacity will be set to 0.1. A refraction, but normally you'd want the refraction to be 0.33, like the actual. Is it 0.33? Is it 0.5 in the real world? I can't remember. But what we're going to do, because if we do any higher, the refractivity of our shader will look very weird, and you can try that on your own, or I'll just show you later on once we get our instance material done. So 0.75 for now, and that's that set up. We'll get into normals and another kind of stuff. Yeah, so what we're going to do is cover the normals and then our world displacement. But instead, what we're going to do is do a little neat trick. So we're going to apply this, and that way you'll be able to see the kind of result we're going to have. So with this, our scattering coefficient. So if you ever done anything in sort of Blender or probably any other 3D package, you might have seen in volumes scattering and absorption. So here, as you can see already, the material looks very intriguing. Just plug this into here and let the shaders compile. And there we go. So as you see, our result for so far is this kind of, well, we get the kind of bluish color, and we also get this depth fade, what we would get in our depth fade nodes set up back in the old back in the previous video, which was like a couple years ago, by the way. And you can there's also this kind of blur you can kind of see between the surface and, well, our landscape surface and the surface of our plane. But as you can see, this is what would more or less would look like down here if you had a higher refraction parameter. So we're going to go back. We're just going to hop back in here, and then what we're going to do is get our absorption coefficient. So we're not going to do that, and just convert the parameter absorption coefficient. 0.0497. Yeah. I'm just looking at my other screen to kind of see what values are, because this is like a big shader, and it's really hard to remember all these numbers which you have to put in if you want to get a good result. Obviously you can experiment on your own, so you can get a shader which will be more to your appeal. And finally, our blue channel will be 0.0137, and we'll plug it in to our absorption coefficient. Did I spell it right? Yeah. I would just apply that. That's all done, and we should see in a little bit our new result. And as you see, from our previous result in comparison to this one, it's much more darker the farther we go, and you can kind of see the colors kind of changing up depending on how close the surface of our landscape is and to our plane from on the z-axis. So yeah, so you kind of can see what we're getting, and yeah. So going back into our shader graph. Now what we're going to do is set up our normals, and later on we're going to also do the displacement. And as you see, we're already at 646 shader base shader pass instructions in comparison with which was about 800 if I'm not mistaken. But well, anyway, what I have done is I've already created my own materials. No, actually no, textures for this material. So if we go into my water, then plug in, and then just see my textures. As you can see, I already have two different texture setups. So just so you can kind of see this, it's called an ocean normal height because well, just the normal height in general. It's the suffix for that. It's because the alpha channel is actually our displacement map, which I packed in using Quixel Mixer. You can do that yourself. I'll have a tutorial for that as well. Actually, I'll have a tutorial built into this. But yeah, so you can kind of see all the blacks are making the normal map all transparent. So we can and yeah, and also when you import, actually yeah, that's fine. You can use this. You don't even have to go into BC7. So yeah, this is a 2K texture. You can go higher if you'd like. That's only depending on how much your graphics card can support. And anyway, what we're going to do is plug in one of this and then convert it into a parameter. So you can, if you want, change the texture during runtime, and then just yeah. I'm just going to call it the ocean normal, and then duplicate that, and then what we're going to do is our water normal height, convert to parameter, detail normal, and duplicate. So now what we're going to do is set up our UVs so we can control them, so we can scale them up, speed up. We can speed up how fast the ocean's going, we can also rotate, which is fun. So yeah, so what we're going to need is our texture coordinate, then multiply that by the what I'm going to do is just set up for ocean normal, so because it'll be all the same actually for all of them. So you can have just one of these and just plug into all, but this just looks much cleaner to me. So do what you think's best for you. What works best, actually. That's probably sounds better. I was just thinking. And one more. I'm just kind of arranging it so it just looks all neat, so we don't get spaghetti code. No, actually no, we don't need that. We'll need the what is it called? Just a constant parameter. So we're just gonna call this ocean normal scale, and forgive me from sorry for how clicky my keyboard sounds. I could have gone for cherry red, but instead I went for the cherry blue because I like how clicky keyboards sound. But yeah, and also it's kind of annoying everyone in my house. So yeah, we just connect that there. Now, what we're going to do is for our panner node, do this, and do it the same place here. Afterwards, we're going to do a function call for a custom rotator. So this is a material function given to us by default inside of the Unreal Engine, and you can look into the code yourself. So what we're going to have to do is connect the panner here. We don't have to connect anything to here because the default will be what we're going to need, and then duplicate that and plug it in. To be honest, I could have just sped up the process by just doing one line and then doing both, but I'm not thinking straight to fill this. So I'm going to do this ocean rotation, and it'll be to 0. We're going to set the slider to max of 1 because 0 is 0 degrees, and once you go to 1, it's 180. Wait, is it 180 or is it a? Actually, yeah, it would be 180, I think, because I think it goes in pi. I think. Actually, no, it's 360. You can see it otherwise if you just hover your mouse over it. Just connect to both over here, and finally, we'll create an append node, which will go into our speed pen. So we get an append vector like so, and if Unreal Engine doesn't start lagging for some reason, we'll do 2 parameters, ocean 1. Actually, so this is when it gets slightly confusing, but I'm gonna just remove this and then just copy these 2, because yeah, we're gonna do that, then set up our detail rotation, detail normal rotation, ocean normal. I'm just giving them more conventional names. So once we go into our parameter, once we go into our instance shader, I don't like to call it parameter. It's just much more clear name. And yeah, plug it in here and there. Over here, we're gonna have here. So for these 2, we're both gonna have separate UV scalings. So we can do so yeah, detail normal scale, and a normal 1 scale, and just give it a parameter of 1 over here as well, but I'm just gonna give this a different name, which will be not here, over here, and there. So back to our pen node, because we'll have 2 sets of these, so it's gonna have that there, and these both are gonna be 0, and this will be our ocean. How should we call it? Because I have on my previous shader, which I was showing you at the beginning, we have very confusing names, and I want to kind of right now kind of adjust it better. So I'm just going to call this normal set 1 speed x. So it'll be in the x direction, and here will be in our y. And then what we're going to do is, so our normal set will be 1 ocean normal and 1 detail normal. So that's 1 set of that. And will be set to over here. And we're going to plug it into our speed pin over here. I'm just going to double click on the line and just give it more neatness. And then plug it into that one there. And just kind of going to make it all nice and in line. Yeah. And what we're going to do afterward is just duplicate, so just do Control W. That's how we've always been doing. And then we're just going to change the number up over here and over here. So we've got ocean normal set 2. And then plug it in there. And then there. And that's us there, and we're just going to plug into our UV pin there on all of our textures. Just going to plug it in there. Why is that? Okay, yeah, because we've got these brackets. So yeah, we've got that. Now, we obviously, each pen can only take 1 input, so we're going to have to kind of do some fun maths, and instead of LARPing, everything, we're just going to do multiplying, and the only LARPing we'll do is between the detail normal sets and our ocean normal sets. So so we're going to multiply these. We're going to multiply both of these. Afterwards, we're going to LARP the 2 of them. Then our alpha will be determined by a single scalar parameter, which will be ocean to detail blend, and we've got some weird typo there, and that's that. And then just plug it into here, and then plug that into our normal. Now, as you see, this looks very long-winded, and probably once we apply the entire thing, it's going to be just all messy and yeah, it's not going to be the greatest. Okay, and it hasn't really increased that much, which is, as you already see, it's a massive benefit in comparison to our previous shader from a couple of years ago. I'm just talking like I'm proud of it, but well, I'm still am because I kind of figured it out at one point, and well, I kind of thought of it, and then yeah, really like that. So now what we're gonna have to do is, well, you can see the results of it already. That I mean, in comparison to that over there, it still looks very different. I mean, it's not moving at the moment, but because actually, I haven't even created a instant shader. So we're just right click on it, create material instance, and there we go. And I just realized that if I don't save this, I'm going to regret it later. And there we go. I'm just going to save that. Just going to yeah. So what we're going to do is click on our plane or whatever object you've picked, and I don't know, I was applying to mesh, and just plug in here. And now, because we've got an instance plugged in, we can actually play about with all these beautiful parameters. Wait, I'm just going to have it on the side. So you don't have to touch. Actually, we're going to up our metallic to 1. Actually, I'll just keep it at 0 for now. So what we can do, because we just need really small numbers to really see this. So let's set this as 1 and up to -1, which already is really fast in comparison. So yeah, we've got this. I'm gonna just give it a diagonal of 0.5. Not that one. That one. So yeah, that's already really fast. So we're going to do just divide it by 10. No, let's do 50. Then divide that by 50. And it's going really slow, so we're just going to so you can kind of play about with this. I'm going to just play about this till I get something good, so I'll just skip this part. So yeah, I've got something of a decent result, but I feel like what we're going to do is scale this and these two. So to be honest, I could have just given both the same numbers, but well, the same parameter. But I feel like it's gonna give us something much more unexpected, I guess. That's the word I'm probably looking for. And this will be okay. So it's higher numbers. We really need to do it. So you kind of see that it's very uniform, right? As you can kind of see in this, like it just comes into a line right there. I mean, right now this is a bit more straight up, like more exact numbers. Probably would get, yeah, this looks more slightly random, but As you can see, it's not the best. And that way, and then let's give it like a font C. That's very jittery. 0.5. Actually, yeah, we haven't even seen our detail normals because of the scale and everything. It should be 0.5, so it blends between the two. And we've got both now. Yeah, it's not perfect. I'll show you the shader which is used across all these planes. You can see over there. See, so if you want the numbers I use, you're going to be able to do that later on in the video. Yeah, I mean, obviously this is not going to match the back because it already looks very different. Yeah, so let's go back into our main shader. I'm just going to close that instance there. What we're going to do is set up our the rest of this output there. So what we're going to need is a caustic texture, which if you've got one, go ahead. I'm not even going to cover. I can't even cover a video on this because I just found it somewhere online and I just use this because I generally don't know how to make caustics myself. They look like you would probably assume more annoying noise. And then just a bunch of tweaking and playing a bit with our post-process stuff, but I don't even know exact process. I'm not exactly a genius on this. Maybe not genius. Just don't know really how to do it. So yeah, actually we even need to drag two of these because yeah, there's no need. But it's just a simple black and white texture, so yeah. So what we do is we can just give a parameter name of Caustics. Then what we're going to do is set up the UVs for this one. Now, the UVs for this one will be in a way where no matter in what position no matter what position and how the two different planes are, which are the same scale, as long as they just touch but don't intersect, the caustic will always be perfectly in line and won't be off scale or offsetted in any direction, which is the X and Y, because Z is not possible on a texture. So what we're going to do is get the world position, which is up here. So it's going to be the absolute world position node. Then what we're going to do is do a component mask. We need the RNG, so the X and Y. As you can see, it's over here. Like X is always red, Y is always green, and blue. Sorry, Z is always blue. So yeah, what we're going to do is multiply this by our caustic scale parameter, so just a simple scalar, caustic scale, which will be a very tiny value of 0.001. So it's 3 zeros and a 1 after the point. And then we're gonna get a pattern node, and then a add node, and plug into UVs. Also a append vector, like so. Two scalars, which is this caustic 1CX, and I just somehow managed to mess that one up. There we go. And speed Y. And just looking at that, and enter speed node pin. And yeah, so that's that for our first texture. For our first texture, we're just gonna copy these two, because the scale will be on both. Plug in that there, change that into 2. Get another texture, or just duplicate your Caustics texture. Then what we're going to do is add these 2 textures together, like so. I'm losing a bit of space, so just make this all neat. I'm going to move our normals just a bit far off to the distance, like that. And then get a atmospheric light color, or light vector, or atmospheric light color. And then after multiply this by what we get from our add value. So it's going to start looking more. Actually, we won't be able to see this. I don't have live nodes. I only have live preview on this. It's already taking a while to calculate because it's getting bigger and bigger. We're going to afterwards multiply the result of that by a scalar of light color. So because the atmospheric light color parameter is very, very intense. Actually, no, very, very low in numbers. So we're going to increase this by 100, and then in our instance we can adjust it to a much more suitable like power output, and just plug into our color scale behind water. Now I'll tell you about this add in a little minute, but we're just going to give us both 0 because we don't need to add anything on top of that, and that should give us another really cool result, which is, because Caustics normally are very expensive or just really something hard to do, but with a single layer of water shading model, it just gives us a whole new playing field of just doing them easy and just making it look well. And that's done. I'm just going to wait for our shader to compile. And there we go. So you can see the Caustic goal is about there. I mean, it's very large. Might have to scale that down. But I mean, obviously, you can see the pixels. But once we start moving this, or actually, let's just adjust this a bit because it does look a bit too large for what's going on in our water. So as you see, it's nearly 700 extra instructions, and the amount of node setup we already did. It's quite surprising, isn't it? But yeah, our caustic scale. I have to really. I'm gonna make this like. Why is our caustic scale not doing what it should? Okay, it's connected to as a scale. Might have messed up on something. Shouldn't though. It should be right actually. Might have to look into that later. But if we do 1 1, then -1 and -1. Ah, okay, I know why. I might know why. This should not have changed at all, because in these pins we're gonna actually do something really cool, which is something which you might have seen. So for some of you might have seen it before. It's called a flow map, which is essentially just a normal map, but it's designed to create the illusion of water the water surface kind of splitting depending on how you define the flow map. kind of splitting a lot between where it's colliding with a surface, which you obviously see in real life, like you see a rock, and I might just stitch in something into the video to kind of give you a visual kind of representation. Now, hopefully, you might see a better result than that. Well, we've got something. And I don't like, did I open Discord? I don't want Discord right now. Yeah, so that's very odd behavior. Could it be that? Okay, this is too large, mate. Too large. Yeah, so the only problem with absolute warp position is that you're going to get a gigantic caustic, gigantic like UV stretch, so you may have to be careful about that. In fact, very careful about it. I think it's just not working at all, unless we give us like tiny decimal values. Like, let's see our light power. I don't think that'll do anything. Okay, apparently the shader is behaving weirdly. We're gonna have to look into that later. But, yeah. We've got that set up. So what we're gonna do now is get our... I'm just looking at my previous kind of shader stuff, but I'm trying to understand why did I do that and the way it's set up. Right. Okay. Okay. I see why. And it's done that way. So what we're gonna do is get another lerp, then just connect our ocean to the A pin, and then what we're actually going to do for this one, because it's it would be, this one is technically the smaller normal. This is like the large, so you get like the general the general kind of like normal general details of it, so like how curved waves are, and this like gives it more definition. But let's get our caustic displacement, because what we're going to do is get our normals very displaced, just very non-uniform to look like, and then just give this 0.5. Connect it into here, and our B, and our alpha will be the same as our blend, and then yeah, I'm just gonna plug that in. Do we plug it in? No. Then we don't even need this one actually. We don't even need it. We're just gonna get a component mask. Separate the blue channel out, and then plug it in to add, like so. And that's us, actually. Actually, no. So I didn't cover this yet, but the phase G, and as you can read here, essentially it's how the light is interacting with the surface. So essentially, if you have a phase G of 1, so it will basically be passing right through the surface, as if light would be passing right through the surface of our shader plane. but its negative one, it's like a mirror reflecting where the light, it's like a light laser just bouncing off in the other direction, which we don't want. So we're just going to give 0.5 value. Actually, no, we're just going to give it something close to 1, but never actually 1. So, but we'll do phase G in a minute. Let's just apply this, and just so you can see the result for now. Because once we do the other one, it's going to be very odd. Oh, there we go. We can kind of see something now. So yeah. So these are caustics, or like the really bright stuff, and as you can see, they look very different to what they look like on our texture. Not this. There. Let me show you. So instead of this, which is already a very tiny texture, but you can kind of see it looks like more curved, and this just looks more aggressive, like noisy. Which you can obviously change it up, but the caustic will essentially be moving it at the same speed as our ocean. So it will look very well. Basically, it looks like the light is actually reacting to the normals of our plane. And I did not mention at all, but see this plane? I did make a custom plane inside of Blender, which is which is 10 meters, so it's a 5 by 5 on the normal grid scale. So like on the 1 centimeter. And it's like you can kind of see even from the number there, it has multiple triangles. So that way, we've got enough just base geometry for our world displacement. Not too much. So once we set up like a very smart function where essentially based on from our distance to the plane, we'll gain some level of tessellation, but not instead. It's constantly tessellated no matter where you're at. That way we can save on some performance. And I am running this on. I'll just display it on the screen during editing. I am running a GTX 960, so which has been running for like 5 years on this machine. I haven't upgraded in a very long while, as you can see. But yeah. But yeah, you can kind of see the kind of result we're getting. Once you kind of play with values, you can get something a bit more nicer. I did mention that. I'll show you the values later. But yeah, the phase G node is gonna be at number of 0.1. Actually no. Let's do 0.9. It's gonna be a normal scalar. We don't need anything special. So we just need 0.9 for now. And if we don't like it, we're just gonna get something different. Wow, where was I? Yeah. So what we're going to do, checking, so really weird normals, very bizarre normals. But just checking, just gonna see where we are. Right, yeah. What we're gonna do is do our world displacement and tessellation. So, which is very simple. I should have probably mentioned at the start of the video, but I completely forgot about it. Setting this two-sided. Then, just scroll all the way down to tessellation and flat tessellation. So you have these two pins enabled, and you can play a bit with these. And yeah, but first, we close this down. Is set up our two functions, which I already have. So it's going to be a bit awkward, but not that. No, real functions there. No. Weird. No, not there here. So what we're going to need is the displacement control and the smart displacement. I'm just going to copy these in the folder like so. So first of all, our smart displacement is going to be. Is it? No, I don't think I'm using that one actually. Sorry. So yeah, we don't no, sorry, we don't even need the smart displacement. It's gonna be the same, but slightly it's gonna be more. So essentially, the smart displacement is actually just these two combined, but I've separated them out. So it's just so we have more control over. We're gonna copy this, put it into our little folder, and there we go. So first of all, what we're gonna need to do is set up our camera position mask function, which is very simple. So all you need is a camera position, like so. Then plug in. Then we're gonna subtract our camera position by our absolute world position, which is excluding material offset. So we just so instead of this, we just set to that. Then we get our vector length in vector 3. Then get the vector 3 length, which will be subtracted by our view distance starts offset, and it will be by 500. And our divide will be, and then we're going to divide that result by the view distance, and as you can see, every 500 Unreal units, it's equivalent to a meter. And then saturate out, invert it, and that's our result. So I'm just going to show you what kind of result we get. So I'm just going to create a quick material like so. Get our MF okay, apparently we can't even see it from here. So we're just going to get our camera position mask and plug into our base color. That's all we need. This is, you don't have to do this step. I'm just kind of showing you, well, giving you a visual representation of what it's going to be. So we're just going to plug it in here, and you'll see what it's going to be doing. So, as you can see, it's black. So essentially, our camera position, it's essentially a smart mask where it's based on the position of our camera, and it's essentially just set a radius of for each pixel. The scope becomes white, as you can see this, which will be very handy for our displacement. So that way, anything in the black will have a tessellation a multiplier of 0. So it will basically revert to base vertex count of our plane or any other object you have the material connected to. And then anything in the white will be actually, I'm just going to turn this into instant because it'll be easier. So anything in the instance, actually not in the instance, sorry. Anything in the white will be immediately set to a camera essentially will be into tessellation multiplier 1. So controlling our view distance, you get the size. So essentially in this radius, all this stuff will be affected. And we get our start offset. To be honest, we really need the two. I'm still trying to figure out how we can kind of smooth this so we can give us a little fall off. I have to look into that later. I'll do a video update on it later. But yeah, that's the basics of that. So I close this down, and yeah, so that's our camera position mask stuff. I'm gonna remove these two because we don't really need it. It's the example shader, which we don't need. Well, now I was thinking about it. Probably should have deleted it because then I can show you also the displacement control function. And our displacement control function will be is going to be controlled by two inputs, which is our height map, so displacement map, which will be done by our alpha pin, which is our displacement, which I packed into this sector, which is going to be then after it's saturated. I'm going to behave as a lerp. So essentially, what we're going to have is anything which is going up. So anything from 0.5, sorry, something. Any color number is, sorry, any number on the texture which is higher than 0.5, it's going to go up by, it's going to multiply itself by 4 centimeters. So if it's going to be 0.51, so times it by 4, it's going to go up by 2 centimeters. And if it's 1, it's going to be 4 centimeters. And if it's below 0.5, it's going to be by -4, because 4 times -1. And then it's going to be multiplied by our tessellation mask to the power of 0.1. Afterwards, we'll be multiplying that with the vertex normal in world space, and we get the world result of our displacement. So essentially, this is just mainly control our displacement, and because the tessellation mask is essentially also, well, is going to be our camera position mask, as you see over here in the font browser, and it's going to also tell which part is displaced and which one isn't, depending on the position of our camera. So yeah, so that's that. Now just connect all the logic up, and we're going to get our camera position mask, like so. Afterwards, what we're going to do is get 2 multiply nodes, multiply it by the 2 alpha channels of our ocean normal textures, and this one by our 2 detailed normal texture, like so. Then lerp between the 2, which is going to be defined by the origin to detail blend, alpha. Then get our displacement control, connect the result height map over here. Afterwards, get our tessellation control to our camera position mask, and connect that into our world displacement, and our tessellation multiplier is going to be in our camera position mask function, like so. So there you go. It's basically all of this is what we've done. Sorry, what I've done in my time, and yeah, you probably could. Wait, can you? Would it be a better way to do subsurface. I haven't really looked into it, but I might do a little update if I get to it at some point on just getting subsurface. So essentially, I'll show you later, but we can save this material. And this might take a while. And there we go. You may also want to do AO, so you get better shadowing. I do have to warn you, you don't have to do it, but do it at your own will. I'm just checking if there's anything. I don't really, I don't have to do it. I haven't done in this video, which probably should have. And yeah, no, it doesn't matter. But yeah, that's that. And now if we just close this down, wait for this, or actually maybe not because it's not there. And there we go. As you can see, it's a bit slightly darker color being displaced, I think. Wait, has it been displaced? You can see it based on, yeah, so okay, yeah, it is displacing, I think. Yeah, okay, it is displacing. You can see the blue polygons there. But now I'm going to show you, as I did say, on the parameters that I've set up, which is this one, I think. Yeah, I was experimenting with parallax occlusion mapping. I did not recommend it for this one, but our number, so you can see our parameters are very different to my original. So if we do actually copy this, so our caustic speed is going to be this. Anyway, yeah. Yeah. If you really want to look at numbers, so there you go. These are the caustics. You want to ignore this. These are the same name. These two are the sets in the normals. And yeah. And yeah, so yeah, that's our wave to detail blend, which is our ocean to detail blend. And there, yeah, so there you go. I'll just leave the numbers also in the description. So yeah. Anyway, that's all what I've got. And you get this kind of cool result, and this is what more or less the actual the caustics are meant to look like. So let's bump the number for them just a little bit. They're more visible, but yeah. More visible based on the distance between you and your landscape or any other object, and they're very displaced, so they look more random. So we look slightly less tile. I mean, you can kind of see the tiling already here. So yeah, that's all I've got, and I'll sign out.